Today you're going to learn about Chapter 16. Yay! The first thing is kinetic theory. Kinetic theory is an explanation of how well particles and matter behave.
There are three major conceptions to find the behavior in particles.
1. All matter is composed of small particles.
2. All particles are in constant random motion.
3. These particles collide with the walls of their containers.
Visualize this. Tennis balls bouncing all over a room. This is like particles in motion.
Wow! We're tennis balls bouncing all over a room! Thermal expansion in gases. An example of thermal expansion in gases is a hot air balloon. In this example, Joanna is a hot air balloon, and Mallory, Ivy, and Hannah is the hot air pushing her up. The air in the balloon is heated, causing the particles to become distant. As a hot air balloon expands, the number of particles per cubic centimeter decreases, which means the density decreases.
This is thermal expansion in liquids. The separation of the particles causes thermal expansion. The addition of energy causes the particles to move faster. Particles move farther apart and expand, showing a change in temperature standard.
This is a thermometer. When you put a thermometer in boiling water, it rises up, well, the mercury in it rises up to show how hot it is.
Next is boiling point.
Boiling point is the temperature at which the pressure of the vapor in the liquid is equal to the external pressure acting on the surface of the liquid.
Not boiling.
Just bubbling.
Boiling point, 100 degrees Celsius. Diffusion of gases.
Diffusion is the spreading of particles evenly throughout its container.
Gas particles move so quickly and so far apart that they overcome the attractive forces between them.
Because the attractive forces are overcome, gases do not have a definite shape or definite volume.
Movement of particles causes diffusion.
Thermal energy.
Thermal energy is the sum of the kinetic and potential energy of the particles in an object transferred by conduction, convection, and radiation.
For example, if you put an ice cube in soup, it moves. How could a solid ice cube have motion? Focus on the particles. Atoms in solids are held tightly together by the attraction between the particles.
And the thermal energy in the particles is causing them to vibrate.
Okay, temperature is the average kinetic energy of particles in a substance. Water molecules have lower average kinetic energy at 0 degrees Celsius than water molecules at 100 degrees Celsius.
Okay, next is the flow of liquids. If you pour cold vegetable oil into a pot, the flow is slow. But if you pour hot vegetable oil into the pot, the flow is faster. How is that? That's because of viscosity. While hot liquids has a low viscosity, then colder ones have a higher viscosity because their flow is slow. Particles transfer energy to particles which are stationary. If the flowing particles does not effectively pull the other particles into motion, then the liquid has a higher viscosity, and the other way around, if the flowing particles effectively pull the other particles into motion, then the liquid has a lower viscosity.
The next topic is the 4 states of matter. The first one is the gas state. Gases do not have a fixed volume or shape, and they spread to fill their entire container. Also, they have enough kinetic energy to break all the attractions between each other.
Solid state. The particles of a solid are closely packed together, and most of them have a specific type of geometric arrangement, and the geometric arrangements that are formed by solids are very important. An example of a solid is an ice cube. For liquid state, what happens to solid when thermal energy or heat is added to it? Think about an ice cube in hot soup. The particles in the soup and the particles in the ice cube collide and they move faster. The collision of the particles transfer energy from the soup to the ice cube. Soon the particles of the ice cube have enough kinetic energy to slip out of their ordered arrangement, and the ice melts because the particles aren't together, and this is known as melting points.
Okay, so the fourth and final state is the plasma state. Most of the matter in the universe is plasma. Plasma is matter consisting of positive and negative charged particles. Its overall charge is neutral because it has an equal number of both charges that are present.
Blue.
First.
Today, you're going to learn about Chapter 16. Yay! I did 6-6 twice.
Oh my god.
Say that for bloopers.
Seriously, don't delete that.
Supposed to be. First thing is kinetic theory, which is an explanation.
You got elbow hurt?
Stop the camera. Okay. Next is boiling point.
The next topic is the four states of matter. The first one is the gas state. Gases do not have a fixed volume or shape, and they spread to fill their entire... What was that?
Next is boiling point.
Boiling point is the temperature at which the vapor of the liquid is equal to the external pressure of the vapor acting on the outside of the container.
Whoa, a random particle. Just floating along.
Jellyfish.
Water molecules have lower average kinetic energy at 0 degrees Celsius. Oh, sorry, guys.
Next is boiling point.
Boiling point is the temperature at which the pressure...
Surface.